Okay, in this video, we're going to investigate this function S3, is it continuous or not, right? So let's go ahead and proceed. Let's go ahead and check. The first check is we take the limit as x approaching 3. And notice that I'm not doing the 3 plus or 3 minus because here we have two pieces. The first piece says when x is not equal to 3, right? And when we do the limit as x approaching 3, if you're looking at the function, again, for the limit, x is not exactly equal to 3. So for this, we actually refer to that. So with this being done, we can just say the limit as x approaching 3. Let's write this down, 2x to a second power minus 5x minus 3 all over x minus 3. And now, if you put 3 into all the x, on the top, if you work it out, you will get 0. On the bottom, if you work it out, you will get 0. So this is a 0 over 0 situation. Well, let's do more work. And in fact, for this one, we can just do the algebra to finish this, right? So if you factor this out, you will actually end up with x minus 3 times 2x plus 1, right? So just work it out real quick on your own. And now you see that x minus 3, they cancel each other out. And then, of course, we can just put in the 3 into this x, and we have 2 times 3 plus 1. And in this situation, in fact, we get 7. Okay? And now, notice that if you are calculating the function when x is exactly at 3. So if you're looking at f of 3, this right here by definition is equal to 6. So notice that the limit is 7, but the value of the function is 6. Of course, they are not equal. However, because the limit does exist and it's finite, so that means, this is not continuous, again, because this is not equal, but the limit is finite, so we actually have a removable discontinuity, right? So I'll just write this down here for you guys. F has a removable discontinuity at x equal to 3. Why? Because I will just tell you the limit of x approaching 3 f of x. This right here is equal to 7, which is finite. And again, if you are ending up with like negative infinity or positive infinity, let's consider a vertical asymptote. You will categorize it in that way. Because this right here is equal to 7, but f of 3 is equal to 6. So in another word, the limit as x approaching 3 of the function, this right here, it's not the same as f of 3, right? So that's pretty much how you can say it. Then that's how you can say there's a removable discontinuity. Now, if we want to graph this, this is how we can make it happen. Okay, when x is equal to 3, right, that's our main focus. So just have a look right here. Well, the limit is going to be at 7, and that's an open circle situation. So I'll just put this down here. So you will get a 7 like this, okay? Well, how can we graph this function though? In fact, if you simplify this, you end up with 2x minus 1, okay? So if you just go ahead and graph 2x minus 1, you know when x is equal to 0, you get 1. So you have a 0, 1 right here. And you can just go ahead and draw the straight line like this. And again, this is how the graph will look like for this right here. And again, you have an open circle because x cannot be equal to 3. That's why you have an open circle, right? And when x is exactly 3, it's 6. So I will just have to come here and just perhaps label this right here to be 6. And we have a closed circle like that. So as you can see, this right here is the graph for this function. And when x is 3, this right here, it's a removable discontinuity, right? The limit does exist, it's finite. And yeah, suppose if you make this to be 7, well, you will be able to fill in the closed circle. You will be able to fill in the hole to make that continuous. But anyway, this is it.